Hey guys, welcome to my channel. Today in this video, we are going to be analyze and do exploratory data analysis of this 120 years of Olympic history, athletes and results data. So we have data in here. The columns in the data set, we have around 15 columns in our data set. ID, name, sex, age, height, weight, all these details are of all the players who participate in the Olympic, right from the when the Olympic was started to the 2016, I think. So this is the data we have: ID, name, sex of those players, age of those players, height, weight, team, NOC, games, year. So these are some of the columns on which we will be working. You can follow along with me if you want to learn, and you can download this data set from by clicking this download button here. I have already downloaded, so I will not re-download it. I have already, you can see, yeah, I have already downloaded. You will download in a, whenever you will download, you will click here, you will get an archive file, like it will be in a zip file, and you have to extract the files from that zip file, right? So let's get started. It will be very fun. We will get to know a lot of things after analyzing the data of this 120 years of Olympic history athletes. There are total, the size of this athlete event.csv. There are actually two CSV file in this zip file: athlete events.csv and NOC regions.csv. So this athlete event.csv basically contains all the details about the athlete who have participated in the Olympic, and this NOC regions contains all the details about the countries, like what exactly is the meaning of this AFG. Whenever you see matches, they don't usually represent they do not usually represent the whole name of those country. There are kind of code of that country. Like for example, they want to show you the there is a match between Afghanistan and India. There would be IND representing India and AFG for Afghanistan, right? So we have all the details of those things. I want you to download this data set and follow along with me so that you can understand more. We will be analyzing and doing this exploratory data analysis in the Jupyter notebook. So I hope you all guys have already downloaded your Python, latest version of Python, and already installed Jupyter notebook in your laptop or desktop. We will be doing this project on in the local host. So let's get started. So we have this Jupyter notebook in here, Olympic data analysis project. You can show this project for your to while having interview for your internship or job. If you are like if you are doing BTech, or you are in second year or third year, it will be very beneficial for you. Or if you're from some other courses and if you want to uh, pursue your career in the field of data analysis, data analyst, business analyst, data engineer. So this project is going to help you a lot in getting those jobs, those internships. So it's better to have a good idea about how to perform these projects, and what are the things you should care about. I will elaborate each and every topic in detail in this video. So kindly stick to it and subscribe to my channel. If you are new to this channel, then subscribe and share it with your friends to whom you think they also need to learn this. So let's get started. So first we have Olympic data analysis. This data is from 1896 to 2016. 120 years of the data we will be working. So this is a great achievement if you complete this project for you. So in this project, we will analyze the data set of Olympic of the year 1896. I just wanted to let you know that the Olympic was first played or first organized in 1896, and from then it is so much popular in the world. So in the first and foremost thing we will do when we start a project in Python, we have to import the important and required library for the analysis we will do. So we are going to need the Numpy library. We will be also required the matplotlib.pyplot for diagram and presentation of those data into tabular or graphical representation. In order to, we need this matplotlib.pyplot. So we have taken the alias of this numpy as np, import numpy as np. Whenever we import a library, we write import and and the name of that library. And then if you want to have some alias, like we don't want to write numpy all the time whenever we need, we can use this np instead of the whole word numpy, right? So we have also imported the pandas as pd, seaborn as snss, and seaborn and matplotlib does the same, almost same things. All these two libraries are used for the graphical representation of the data. So let's just go ahead and import all these libraries. In order to run a cell, you just I am assuming that you are so beginner, and you do not know nothing. You know nothing about this Jupyter notebook. You are very fresher. So I'm going to tell you each and everything. I think that is important, right? So in order to run a cell, you just have to click the shift plus enter button, right? Shift plus enter. So there you go. We have successfully imported all the required library. Now, first of all, after importing the libraries, we have to load the data set, right? We have downloaded the data set from this Kaggle website, right? And after that, we can load that data set into our Jupyter notebook. In order to do so, since the file is in CSV format, we are going to PD. PD means I am using this. I could have written pandas if I had not taken the alias pandas as PD, right? So PD means pandas dot, there is a method inside the pandas library, read CSV. It basically helps us in reading a CSV file. So I have taken athlete's name of that particular CSV file, and pd dot read CSV, and then provided the path, the whole path of that file. And there are actually two CSV files in this data set. So the first one is athletes, and the second one I have given name of regions, because it actually contains all the details and the data of regions only. So pd.read CSV and the whole path of the NOC regions.csv. I don't think you would have any doubt till now. Now let's take a glance at the data using the head and tail functions. The head function and tail function inside the pandas, or in whenever you're working with some data set, helps you to uh, take a glance at the top 5. If you want to take a look at the top 5, the first 5 rows, then you need to have a head function. So this basically head function helps you to take a glance at the first five rows of the data set. So Let's first of all load the data, and then you're gonna take a look at this first 5 rows of the data set. So we have name of the player, sex, age, height, weight of that player from China. Its AG Hang was from China, and the code word of this China is CHN. The game was 1992. Summer Olympic was there. The year was 1992. The season was summer. The city in which this Olympic was organized was Barcelona. The sports ADG Hank AD Jank used to play was basketball. Basketball men's football was the event, and the medal he won was none. So now let's take a look at the last. Oh, sorry, it was head. Now let's me type the tail. Now if I want to take a look at the last 5 rows of this data set, then I will have to provide it tail, like regions, the name of that data set, and then dot, and then tail, and then curly braces. Okay, so we have the tail, the last 5 rows of the regions column of the regions data set. Now let's take a look at the descriptive stats of the data set on which we are going to work. Like we want a description of this data set. Like I want to let me show you what is it. So the count, it basically gives you some of the descriptive statistic of that data set. It will provide you the count, mean of the various, all the numerical columns. If you can take a look at this data set, then you can have a look, like the ID column is numerical column, uh, name is text or a string column, sex is string column, age is again a numerical column, height, weight, and this year is numerical column. So whenever it sees a numerical column, it basically provide you this descriptive statistics, right? So the count, there is no use of this count, right? The mean, we can take a look here. Mean, the average age of the average age of all the player in the Olympic history is 25.5 year. So around the average age of all the players is 25 years, and the average height is 175 centimeter, and the weight is 70 kilograms. And we can see that the minimum value of the age is 10 years. Wow, this is really amazing. Someone at the age of 10 has played Olympic, and the minimum height is someone of the height 127 centimeter has played Olympic, and the weight is just 25. I think this 10-year-old boy or girl would have the weight of 25 kg and the height of 127 centimeter. And the maximum age is like 97. A guy, how old was he? 97-year-old man or women has played Olympic. That's really amazing. So from this descriptive analysis, this descriptive statistics, we can conclude that the age of youngest player in the Olympic history was just 10 years. Whoa, this is really amazing. The shortest player ever played in an Olympic was just 127 centimeter tall. The average age, height, and the weight of the Olympic is 25 years old. The average height is 175 centimeter tall, and the average weight is around 70 kilograms. The age of eldest player in the Olympic history was 97 years. The tallest player ever played in an Olympic was 226 centimeter tall. It's so tall. So just one line of code, just 2 words, the name of that data set and dot describe can provide you so much information. So this is the power of Python, guys. We have extracted so much information just in just one line of code. Now let's join the both data set. We have two data set, athlete and that region data set. So I want to join both of the data set. How would I do that? So joining the data set is very easy in this Python. So you can provide a name of that join data set. I want that join data set as df, the name df. That df represents to data frame. Athletes, provide one of the data set in front in the first place, and then dot merge, and then second data set whose name is region, and then how would you want to join those two data set? So I want to join left join. I want to do a left join, and on which column? The NOC column. Just one line of code and you have successfully joined both of the data set. Now let's check the shape of the data set. Like now, how many number of rows and columns do we have right now after joining this? So there are around 2,71,116 rows, total number of rows in our data set. So this is a very huge data set. So you can whenever you will be having a interview with your interviewers for the role of data analyst, data engineer, or some kind of internship in this kind of field, you can tell them, you can specify specify them like you have worked on more than 2 lakh of the you have already worked on a project in which there were more than 2 lakh rows in that data set. So it was very huge amount of data present in that data set, and you have successfully worked on it. You have extracted meaningful information from that data set. You can tell them. So from here, df dot shape will provide you the shape, number of rows and number of column of that data set. And if you want to get the name or get the list of all the columns present in the data set, then you can simply df, that is data frame, and dot columns provide you all the rows present, all the columns present in that data set, the id, name, sex, age, height, weight, and all that. So since we have successfully imported all the libraries, after that we have loaded both of the data set, and then taken a glance of the data set using head and tail function, and then taken a descriptive analysis in which we got a lot of information about the data, and then we have joined the data, both of the data set, and then got to know the shape of the data, join data, and then got the name of the columns. Now we can do something. We can move another one step ahead and clean our data set, because I can see that the first letter of this region is in small and not looking good. The first letter of this notes is also small, whereas you can see the first letter of the all the name of the all column is capitalized, but except for these two. So it is not actually looking good and professional. So let me just rename this column. So how will you rename one column? One thing I have noticed here. So let's make it rename the column names. So df dot, if you want to rename some column, you just have to go ahead and write df dot rename, and then you have to bracket, you have to provide a bracket, curly braces. Did I say curly braces? Sorry guys. df dot rename, and then parenthesis, and then columns equals region, that the name you have already have in here, original name, and then you whatever you want to replace it with. So I want to replace this region with this region, and this node with this node, and then inside a curly braces, and then in place equal 1. If in place equal 1, you can also write, you can in place equal true. So this in place equal 1 or true actually make changes in the original data set. If you do not write this in place equal 1, it will create a temp temporary file of this temporary table of this data set, and then replace or make all these changes. If you write this in place equal 1, it will make changes in the original data set. This is the difference between writing in place 1 or not. So in the first place, we will rename this column and then print the name of all those columns, right? So let me run this cell. We have index. Now you can see that it looks cool, right? Now let's check for the null values in all these columns. How would I do that? None values, I have taken a variable nan values and df dot is na. Nan columns, nan values dot any. Nan values dot if there is any none values in this column, then it will print out all those columns. So as you can see that this first 3 columns has no any none values, but in the columns of age, height, weight, all the 3 columns contain none values. And then we have all these columns shows that false. It means it doesn't have any none values. So the column which are having true shows that they have some none values in them, while those who have false shows that they don't have any none values. That's it. I don't think you would have any confusion till now. Now let's look at how many none values do they contains. I want to know if the age column has some null values, then how many of them are containing? Like if there is 1 or 2 null values, then that's okay. If there is a large number of null values, then we really have to fix it. So in order to get to know that how many of the null values do each and every column contains, there is another function df dot is null dot sum. That's it. This 3 piece of word would actually give you a lot of information about all the columns. So you can very easily see that the age column contains 9,474 number of null values. Height column contains 60,171 null values, and the weight column contains around 62,000 of the null values, where you can see that in the middle column it contains around 231,333 columns which contains the null values. Why does the middle column contains null values so in a large number of? Why is it that? The reason could be there are many players who participate in the Olympic and do not win medal. That's why there is null in front of the medal column. Like for example, the Milkha Singh, who has never won a medal in the Olympic, so there would be obviously null. There would be 0 in front of their medal column, right? So this could be one of the reason, but there could be some other reason also. So there is a quick question. Print the list of those columns which contains at least one null value. How would I do that? So df dot column, df dot is na dot any dot to list. So if it contains at least one null value, it will obviously give a true. And if it is true, then it will print their name. So these are some of the column: height, age, weight, medal, region, notes. These are some of the column which contains at least one null values in them. Since I am Indian, I am from India. I would like to print out the details of only Indian athletes who have participated in Olympic. I just want to take a look at only Indian, uh, only the data of Indian players, right? So how would I do that? So there is another method named query. So df dot query, and inside a parenthesis, you just have to provide it the condition. So the team should be equals to India inside a single quote. You can take a closer look in here. Inside a single quote, provide team. The name of that column should be equal to this value, India. This India is already in a double quotation, and dot had provide me just 5 rows of dot data. So here you can see that all the data is from India only. And S Abdul Hamid is a guy, is a player who had participated in 1928 Olympic, and it was Summer Olympic obviously, and it was held in Amsterdam. He had participated in athletic men's 110-meter hurdles, and he didn't won any medal. So these are some of the players. It was also held in Los Angeles in 1984. This Shinny, someone who was from India, who, and his age was just 19-year-old. So congratulations to him. At a very early of age, he has participated in Olympic. No worries, he has never won any medal. Okay, so I am quite curious about the Milkha Singh. If you are from India, I'm sure that you know Milkha Singh. So let's see the details of Milkha Singh. So how would I do that? So in the same fashion as I did in order to get the details about India, I'll do that for the Milkha Singh too. So df dot query, and the name should be the name column should be equal to Milkha Singh. And then we have got all the details of this Milkha Singh. There are actually 4 rows of Milkha Singh. He had participated in 1956 Olympic. It was held in Melbourne, and he had actually in 1956 he had participated in 2 events, in men's 200 meters and men's 400 meters, and he didn't won any medal. And at the age of just 21-year-old, he had participated in the first Olympic. That's really amazing. Even I am 21-year-old, so I can think that it is very difficult to prepare for such big event at a very early age. And in the next Olympic, when he was 24-year-old, he again participated in Olympic in 1960 in Rome Olympic. It was I'm well aware of the Milkha Singh. I am so much fascinated about this guy. I even watched the video of this final Olympic. It was when he was running in the final in 1960 Rome Olympic. He secured 4th position just because of the point 1 or 2 second. So it was really heartbreaking for me and for all the Indians, because he was just so much close to secure 3rd place in that Olympic. And after that, he also participated in Tokyo Olympic in 1964 at the age of 28-year-old in men's 4 into 400 meters relay race. Now let's do a quick comparison of India and Japan. Like, I want to know all the details about India and Japan very quickly. So we can have we can see that the average age of Japanese player, the average age of Japanese player is 24 years, and the average age of Indian player is 25 years. So we are quite elder than those. The player of India are quite elder than Japanese. Indian players are quite taller than, we can see the average height of Japanese is 168 and the average height of Indian is 171 centimeter tall. So Indian players are about 3 centimeter taller than that of the Japanese player on an average basis. And the weight of, since the Indian players are taller, so obviously the weight of those players will also be taller. So we can see that the weight of the Japanese player are around 63 kilograms, while Indians are around 67 kilograms on an average. Now let's go ahead and find out the top 10 countries with the participation rate in terms of number of players. Uh, in terms of number of players have participated since 1950s. I want to calculate or find out the top 10 countries with participation rate, like how many number of, like India has 200 players participated in the Tokyo Olympic last year. So, and if we compare our 200 players with the China, who had 2000 players participated in the same Olympics, so we can see, we want to find out the top 10 countries with participation rate, how many number of player do each country have. So the data should be, I will put a condition so that the data should be from 1950s. So the top 10 countries, I have taken a variable, and the df dot team dot value counts dot sort value. So df dot team, first of all I have taken the team column, and then value counts, how many number of times those country have came up, and then sort those value, and the ascending will be false, so that I can get the top countries on the top, and I want to get the only 10 countries, right? So here we have top 10 countries. Let's run this cell. So we can see, clearly see that the United States is on the top. So United States is the topmost country from where the athletes comes to participate in the Olympic. United States provides so many Olympic athletes, and after that we have France, and then Great Britain, Italy, Germany, Canada, Japan. So these are the countries from where all most of the Olympic athletes come. Now let's just go ahead and graphical represent the top 10 countries of this the most participation rate. I want a graphical representation of this particular data. How will I do that? I will take help from the SNS, that is Seaborn library, and I will do a bar plot. So PLT, that is nothing but matplotlib.py plot. So PLT dot figure, the size of the figure should be 12:5, and then the SNS dot bar plot, that is X, the value of X should be top 10 countries. This data should be in the top, in the X column, and then top 10 countries index should be on the Y column. And the title, I have provided it. Let me show you, and after that I can explain you will better understand it. From here you can see that the title is, I have given that PLT dot title, the figure of this title. The title of this figure is top 10 country with the most number of player participation. It can see in here the same text is given, and then PLT dot X label, that is number of layer, that is X in here, number of layer, and then we have Y level is PLT dot Y level countries. Here you can see the country, and then we have PLT dot show. So this is a very beautiful graphical representation of this particular data. We can clearly see that US is how much. US is way ahead from the second country, that is France, in terms of participation rate. And then let's just go ahead and solve another question. So the age distribution of player using histogram. How will I do that? How will I prepare a histogram of the age distribution? So PLT dot figure, the figure size should be 12:4, and the PLT dot hist and the df dot a should be first column, and the bins should be 10, from 10 to 60. We have already seen the youngest player in the Olympic history was just 10-year-old. That's why I have taken it 10 year. And usually Olympic players the age of Olympic players lies between 20 to 40 years, and still have taken 60 years old, just as to know ki how many players above age of 40 or 50 have participated in the Olympic. And the color should be green of my histogram, all the bars, and the edge color should be white. There should be differentiation between all the ages of those bars. So you can see in here that most of the players, the age of most of the players is around 20 to 30, and they are more inclined towards 25 year of the age, like around 24, 22 to 26. All the players comes in, and as the age grow up, like there are less number of players in between 30 and 40, and there is very less number of players, the age is 40 to 50, and there is almost negligible number of players above 50. Now I want to print the name of sports played in Winter Olympic. Like I want to have a list of all the games that are played in Winter Olympics. So how would I do that? I will simply just go ahead and take a variable name that is winter games, and then df. Inside that df, I will go ahead and filter out df dot season should be equal to winter, and sports dot unique. So for I in winter games, it will have all the games. For I in winter game, print I, so that I can have a list of all those players. So we have speed skating, cross country skiing, ice hockey. So these games are usually played using some snow and ice, like skiing, ski jumpy, freestyle ski. So these are all the games which are played in winter Olympics only. Now I want to print the name of sports played in summer Olympics. So I did the same thing, just replace this winter from the summer, and we have number of players which are played in summer Olympic. That is the reason why the value of this summer Olympic is way ahead and way greater than that of the winter Olympic. Now I want to just go ahead and take a look at the data. Okay, we have this data, and what if I want to know the ratio of male versus female participant in the Olympic history? How would I do that? First of all, I will just go ahead and count the number of male. So df.sex should be equal to male, and then count the number of those. Female count is the df.sex, that, and say df.sex equals to female, that is f, and then count, and the total count of all the players. And then we have male ratio, male. How would I count the male ratio? Male count, the number of count, and then we have total count into 100, and the int of that number. And the same thing with the female. Let me just show you. So we have 72 ratio 27. So number of male is way greater than that of the female ratio. So the male ratio is 72 and the female ratio is 27. It is, this data is actually from right from the 1896. So in early, like 50 or 80 years from now, there was the world was male dominant. All the male players used to participate in the Olympic, and there was a negligible number of female players in any of the game in Olympic. So that is the reason why we have the ratio. There is a wide gap between the ratio of male and female participation rate. So I want to represent the same data in a pie chart. How would I do that? So this is the graphical representation of the same data, 72.5 and 27.5. So gender count, plt dot figure, we have figure in here, and then the title of this figure is in here, female participation ratio in Olympics since it has started. Plt dot pi, and the gender count, labels equal gender counts dot index auto pct, that is percent 1.1f percent so that it can take calculate all it can calculate percentage automatically. I don't have to do any calculation the way I did it in here. And the shadow equals true, it provides a little bit of shadow. You can see in here, this is shadow. And then pld dot show. So this was the graphical representation of this data. Now, since there is a wide gap between male and female, and we don't think कि ये gap अभी भी है, this gap are not do not persist now in this in the recent Olympics. Like you can, we saw in the last Olympic there were a number of female female athletes who participated in Olympics. So there wasn't, we didn't saw the same gap. So let's just go ahead and filter this data, and we want to take out and work on the data that is let's just go ahead and filter out the data and take and work on the data which are after 1950. So the male count, same thing is, and then we have you can see df.sex. I have taken up only one column, and then we have provided it a filter and then provided it double filter. The sex should be male, as well as the year should be 1950, and then dot count, the same thing for female, and then the year should be equal to 1950. And this, I have calculated the ratio in here, and then so if we talk about the data of after 1950, the ratio, the wide gap of 72 and 27 reduced to 56 and 26. So you can see that there is there is around 30, the gap is 30, and earlier the gap was around 50. So the male and female participation on each Olympic, and the gap between them is we can, let me just show you, and after that I can provide you all the data. So what exactly is the answer, and then after that I can explain it to you. So the male female ratio in Athlena, that was in 1896, it was 72:27, and the gap was 45, right? Male female ratio in Paris, that is 900. Like the first Olympic was played in Athena, it was in 1896, and the ratio between participation of male and female was 72:27, and the female ratio in Paris, which was played in 1900, was 71:27, and the gap was 44. So you can see that there is a decline in the ratio of over the time. There is actually decline in the gap. It was first 45, and then 44, 42, 40, 39, 37, 35. There is always a constant decline in the gap. So by the end of 2000, there was, the gap was around 15:11. There was a ratio, the gap was only 4. And the end of the year in London Olympic 2012, the ratio become equals. The number of male participant and the number of female participant was equal. The gap between them, their participation ratio was 0. So we have now let's see how did I calculate it. So first of all, I just taken out a list of 1896 and 2017 with a ratio of with a gap of 4, right? And name it a year. So for I in year, male count was just the same as I calculated above. So df sex should be equal to male, and the df dot year should be greater than I. So the in the first loop it would be 1896 dot count, and then female count is df dot sex, sex female, and the df dot year is greater than I dot count. So and the male ratio as I calculated above, and the female ratio, and the gap is male ratio minus female ratio, right? So we have taken up all these variable, the gap, and then we have a try function. In a try block, venue should be equal to df dot city, df dot year equal I dot unique. So df dot city, and inside that df dot year should be equal to I, that is the name of that year, should be, and dot unique. And the first thing of that city, and accept venue unknown. So you can simply see that the venue is unknown in here in 1916, and in 1940 the venue is unknown, right? Why is it unknown? It is unknown because in 1944, in 1940 there was no Olympic game because of the World War. During the 1940 and 1944, no Olympic was held anywhere in the world. That is the reason why we have unknown. It actually takes up all the error. So you can see the gap is still persisting, 32 32. You can see the same data has put it forward. So the since there was no Olympic, that is why giving us the unknown, and you can see that everywhere we have the place. So we have printed male female ratio in venue, and then the first venue, and then the year of that Olympic, and then is male ratio, and then female ratio, and the gap is gap. This is how I calculated. And after that, we have graphical representation of the male female participation in Olympics since 1896. So we have graphical representation of the same data. You can see that the gap between the male and female ratio, how it has decreased. And after 2008 it has become 0. That is the reason why we don't have any bars in here. So in the same thing, I have calculated this graphical representation of male female participation ratio in Olympics since 1896. So we have for I in year male count, the same thing I did that, and then bar plot dot I dot gap. So the conclusion of this exploratory data analysis is that of this graphical representation is, at the time when Olympic were started in 1896, there was a large gap between male and female participation ratios. That is around 45. There was around 45 gap. With the time, male female participation ratio keeps decreasing. In the year of 1952, the gap was around 25, and by the end of 20th century the gap came down to just 4 to 5, and in 2012, the first time in the Olympic history, the participation ratio of the male female ratio became 0, and it was London Olympic. Now let's just go ahead and find out some of the problem, like find out the total number of female participation in each summer Olympic. So in each summer Olympic, there were in the year of 2000, the number of female participant was 5,434. In 2004, the number of female participant increased. In 2008, it increased to 5,800, and in 2016, it was above to 6,000. Now let's just go ahead and graphically represent this data. So this is the graphical representation of women participation in only Summer Olympic. I have filtered out this Summer Olympic. You can see in here. Now find the number of male participants in Summer Olympic. So I did that for male also, and compare it with the female. Like how did it happen for the male? How it the number of participation has gone ups and downs, and for the female, you can see in here there was a wide gap. Now let's just go ahead and find out the top 10 country with most number of medals. Who are the country you have won most number of medals? How can we calculate that? Okay, so United States has won most number of medals. It has won around more than 5,000 of the medal is won by United States itself. And you can see it is more than double than the second number, that is Soviet Union and then Germany. It, if you can add the top in the from second to the next 4 or 5 participant team, then the number of more United States medal could be tally. So States are way ahead in winning medals in participant rate. And I think the people from United States are well aware, and they are more aware of this Olympic games. They participate in more number of. Now graphical representation of top 10 countries winning most number of medals. So PLT dot figure, fixed size is 15:4. PLT dot title, top 10 countries winning most number of medals. And the bar plot, SNS dot bar plot. And we have top 10 country with medal in the X, and then top 10 country with medal in the Y, and PLT dot show. And then we have this the graphical representation of this data is in here. Now let's just go ahead and find out the details of those players who have won gold medal and older 60 year of age. We want to know the name of those players who have won gold medal even after being so old, older than 60 year of age. So these are the players: Isaac Leroy, Isaac, Charles, Jacob. These are the players who their age is more than 60 year of age. Like this guy at the age of 63 years has won a gold medal in art competition. He has won in archery, shooting. So this guy are really amazing. At the age of 60, they have won gold medal in Olympic. So that's it from my side for today, guys. I hope you have learned something new in this episode, and please subscribe to my channel if you want to see more videos like this.